This is a multiple choice question about fixing a problem with Gaussian process regression (GPR), a type of machine learning. Break time 300 ms. The goal is to choose the best ways to improve the accuracy of predictions. This introduces the topic. We're dealing with a machine learning model, GPR, that's overfitting, meaning it's too focused on the training data and doesn't generalize well to new data. Break time 200 ms. That's why the predictions are erratic. This specifically describes the symptom of the overfitting problem. The model's predictions are unstable and unreliable because it's learned the noise in the training data rather than the actual pattern. Google style name lively. It's like trying to fit a very complex curve to a few noisy data points. Break time 200 milliseconds. It won't work well on unseen data points. Google style. This option suggests increasing the alpha parameter in the GPR model. Alpha represents the noise level. Break time 300 ms. I am increasing it to tell the model, hey, there's more noise in this data than you think. Break time 200 ms. The model will then become less sensitive to small changes in the input data. Preventing overfitting. This means using a less complex mathematical function within the model to measure the similarity between data points. Break time 300 ms. A simpler kernel will make the model less flexible and less prone to picking up on the noise in the data, therefore less prone to overfitting. RBF stands for radial basis function, a commonly used, relatively simple kernel function. This is the opposite of option D. This option will probably worsen the overfitting. Break time 200 ms. A more complex kernel allows the model to capture more intricate relationships in the data, but also makes it more likely to overfit the noise. To solve this problem, I need to understand two key things: the meaning and effect of the alpha parameter, and how the choice of the kernel function influences model complexity and the risk of overfitting. This clarifies the overall question. We're using Sklearn's Gaussian process regressor, and the question asks us to identify techniques to reduce overfitting. Break time 300 ms. Overfitting in this context means the model is performing well on the training data, but poorly on new data. I see erratic predictions, which often means the model is overfitting. That is, it's learning the noise in the data instead of the underlying pattern. Break time 300 milliseconds. It's like trying to memorize every single word in a book instead of understanding the overall story. Google style name lively. This makes the model really sensitive to small data changes. Google style. We're trying to fix this overfitting in a Gaussian process regression model using Sklearn. Break time 300 milliseconds. We need to find ways to make the model less sensitive to small changes in the input. I'll examine the options carefully to determine the best approach. A simpler kernel, like the radial basis function RBF kernel, will reduce model complexity. Break time 300 milliseconds. Think of it like using a simpler tool for a job. A less complex kernel prevents the model from fitting the noise too closely. It focuses more on capturing the larger trends in the data. Using a more complex kernel, like rational quadratic, can make the model too sensitive. It's like using a super powerful tool when a simple one would be better. Break time 300 milliseconds. This will likely make overfitting worse or better. The alpha hyperparameter represents the assumed noise level. Decreasing it tells the model there's less noise, causing it to try even harder to fit every tiny detail in the training data. Break time 300 ms. That makes overfitting much worse. Google style name excited. We definitely don't want to do that. Google style. Increasing alpha means we're telling the model that there's more noise. Break time 300 milliseconds. This forces the model to generalize better and be less sensitive to small variations, reducing overfitting. Google style name friendly. It's like adding some extra margin for error to make the model more robust. Google style. We're tackling a common problem in machine learning: overfitting with Gaussian process regression (GPR). Google style name excited. GPR is a powerful technique, but it can be sensitive to the nuances of your data. Google style overfitting means your model learns the training data too well, including the noise, and doesn't generalize well to new, unseen data. Think of it like memorizing the answers to a test instead of actually understanding a material. You'll do great on that specific test, but you'll flunk the next one. Break time 300 milliseconds. The specific issue is erratic predictions from the model. Small changes in the input data produce wildly different outputs. Google style name empathetic. This is a classic symptom of overfitting. Google style break time 300 milliseconds. We need to make our model more robust to these small variations. This question is asking us to identify actions that will reduce the overfitting behavior. Google style name conversational. We need to tame that overly sensitive model. Google style break time 300 milliseconds. Increasing alpha increases the assumed noise in our data. Think of it like adding some randomness, forcing the model to generalize rather than clinging to minor details. This helps to reduce the sensitivity to small changes in inputs and therefore decreases overfitting. I would avoid this. Decreasing alpha would tell the model that the data is very clean and precise. The model would become more confident in fitting every single data point, leading to even more overfitting, the exact opposite of what we want. A more complex kernel gives the model more flexibility to fit intricate relationships within data. However, this added flexibility often leads to overfitting as the model becomes too specific to the training data and fails to generalize. I recommend using a simpler kernel. Think of it as reducing the model's capacity for complexity. Simpler models tend to be more robust to noise and less likely to overfit. They are less sensitive to little input variations. We're tackling a problem with Gaussian process regression, a powerful machine learning technique for predicting continuous values. The core issue is Google style name emphasis overfitting. Google style, meaning the model is learning the noise in the data instead of the underlying pattern. Break time 300 milliseconds. Think of it like memorizing the quirks of a few exam questions instead of understanding the overall concept. This leads to unpredictable and inaccurate results when you feed it new data. Break time 300 milliseconds. GPR uses a mathematical framework based on Gaussian processes to make predictions. Break time 300 milliseconds. GPR is sensitive to overfitting. I am suggesting to increase the alpha value. Alpha controls how much we trust the data. A higher alpha means we assume more noise, so the model becomes less sensitive to small data changes. This is good. It prevents overfitting because the model is less focused on fitting every single minor detail. Imagine you have a blurry photo. Increasing alpha is like saying, hey, this is a blurry photo, don't try to recreate every tiny detail, capture the overall shape. I propose to try a simpler kernel function. The kernel describes how points relate. A complex kernel is like using a super precise tool but can capture every detail, which is both very sensitive and more likely to overfit. A simpler kernel acts as a more general approach, preventing the model from overreacting to tiny data fluctuations. It's like using a broader paintbrush instead of a super fine one, getting a less detailed but more stable painting. Decreasing alpha would be a bad idea because the model would pay even more attention to minor changes. This worsens the problem because it would cause the model to be even more overfit. This is like using a magnifying glass to examine the minor details, focusing even more on the noise instead of the actual pattern. This is the opposite of what we need. Choosing a more complex kernel adds even more flexibility to the model. It will try to model all details, noise included, leading to an even more severe overfitting issue. Because that is just adding complexity to the system. It's like using an extremely powerful microscope, capturing excessive detail that may not be significant or meaningful. We're tackling a problem where a Gaussian process regression model, that's GPR, a fancy way to predict things, is overfitting. Think of it like trying to draw a line through a bunch of scattered dots. If you draw a super wiggly line that goes through every single dot, you are overfitting. You are capturing noise, not the underlying pattern. Break time 300 milliseconds. What we want is a smoother line that captures the general trend. Break time 200 ms. This problem shows up as erratic predictions. Small changes in the input lead to big changes in the output. Google style name lively. It's like a super sensitive scale, making it unreliable. Google style. This option is incorrect. The hyperparameter, alpha, reflects how much noise we assume is present in our data. Decreasing alpha means we're assuming very little noise. Break time 200 milliseconds in this case. The model will try to fit even the tiniest variations in the data, making overfitting worse. Break time 150 milliseconds. The erratic behavior will increase. The core problem is overfitting. The model is too focused on the training data and hasn't learned to generalize well. Break time 200 milliseconds. The predictions bounce around wildly because the model is too sensitive to minor input changes. It's like the model is remembering the exact details of each training point instead of the bigger picture. Google style name excited. We need to calm it down. Google style. I like this choice. Break time 200 milliseconds. The kernel function helps the model decide how similar different data points are. A simpler kernel, like the radial basis function RBF kernel, keeps things straightforward. It reduces the model's flexibility, preventing it from getting too caught up in the small details and overfitting the training data. Simpler means less prone to overfitting and more robust predictions. This is incorrect. Break time 200 ms. Using a more complex kernel like the rational quadratic kernel will increase the model's complexity. Break time 150 milliseconds. This can model more intricate patterns, but it also increases the risk of overfitting. Break time 100 milliseconds. More complexity equals more sensitivity to noise. This is the quiz question, asking you to figure out what steps we can take to reduce overfitting in scikit-learn's Gaussian process regressor GPR. Break time 200 milliseconds. We're looking for solutions that will make our model less sensitive to minor input changes and more focused on the general trend in the data. Google style name friendly. Let's find the right answers. Google style. This is correct. Remember that alpha reflects the amount of noise. Increasing alpha simulates more noise. Break time 200 milliseconds. By doing this, we force the model to ignore the tiny variations and focus on the bigger trends, reducing overfitting and resulting in more stable predictions. Google style name determined. This is a good step towards a more robust model. Google style. We're dealing with a common problem in Gaussian process regression. Google style name emphasis overfitting. Google style. It happens when the model is too complex and focuses on the random noise in the data instead of the actual pattern. This makes predictions super sensitive to tiny changes in the input, leading to unreliable results. Break time 300 milliseconds GPR. By the way, stands for Gaussian process regression. I see erratic, unpredictable predictions because even tiny changes in the input data create huge shifts in a model's output. This is a clear sign of overfitting. Let's explore ways to fix this overfitting. We need to make the model less sensitive to noise and improve its ability to generalize to new, unseen data. Increasing the alpha hyperparameter tells the model to expect more noise in the data. This will make it less sensitive to small input changes and thus reduce overfitting. Break time 300 milliseconds. Think of alpha as a knob that controls how much you trust the data. A higher alpha means I am not so sure about this data. So I'll make the model more robust. Using a simpler kernel function, like the radial basis function RBF kernel, reduces the model's complexity. Simpler models are less likely to overfit, they are more resilient against noise and provide more reliable predictions. Break time 300 milliseconds. Imagine fitting a curve through data points. A simpler function like a straight line will be less sensitive to the exact position of each point than a complex, wiggly curve. I would Google style name emphasis, avoid Google style decreasing alpha. That would tell the model there is very little noise in the data. So it would fit the noise more precisely, which would make overfitting even worse. Using a more complex kernel function would give the model more flexibility to fit the training data perfectly but might overfit even more. Break time 300 milliseconds. It is like using a really fancy, flexible tool to cut wood. You can create a super detailed shape, but you are also more likely to make mistakes and get an unreliable result. We're looking for the actions that will prevent the model from being too sensitive to small input changes and improve the accuracy of predictions on new data. I see you are tackling Gaussian process regression (GPR), a powerful technique for predicting values based on data. Overfitting in GPR means your model is fitting the noise in your data instead of the underlying pattern. It's like trying to fit a complex curve through a scattered set of points. You'll get a curve that looks great for those specific points, but it won't be accurate for new data. The goal is to find the sweet spot, a model that fits the data well enough but isn't too sensitive to noise. The problem describes a key symptom of overfitting: erratic or highly sensitive predictions. Small changes in your input data lead to wildly different predictions. This tells you that your model is too complex, overly focused on the specifics of your training data and not generalizing well. Think of it like a child who memorizes the answers to a specific test, but can't adapt to different questions. Google style name lively. A robust model should be like a wise adult capable of adapting. Google style break time 300 milliseconds. The solution involves techniques to prevent overfitting, making your predictions less sensitive and more reliable. We'll explore options to simplify the model's complexity and improve its generalization ability to new data points. This is the core question. We need to identify specific actions within scikit-learn's Gaussian process regressor that will make the model less sensitive to noise and improve its predictive performance on unseen data. The alpha hyperparameter controls the assumed noise level in the target variable. Increasing it tells the model, hey, there's a lot of noise here, don't overfit. It forces the model to be less sensitive to small data variations. I like to think of it as adding a bit of smoothing. Decreasing alpha tells the model the data is super clean, fit it perfectly. This is exactly what we want to avoid if we're dealing with overfitting. It makes the model even more sensitive to tiny variations, exacerbating the problem. The kernel function defines how the model measures similarity between data points. A more complex kernel allows for more intricate relationships. which can be excellent, but also increases the risk of overfitting. It is like using a very detailed brush to paint. It's powerful but might create a result too specific. To the training data, simpler kernels, like the radial basis function RBF kernel, make assumptions about the data that smooth out the model. They're less flexible but more robust. Think of this as using a broader brush stroke. You'll lose some detail, but the painting will be more generalized. This is a key parameter in Gaussian process regression GPR. It's a measure of how much noise I expect in my target variable, what I am trying to predict. A higher alpha means I accept more noise, preventing overfitting. A lower alpha says that I think my target is very clean, which increases the likelihood of overfitting. The kernel function defines the relationship between different data points. In GPR, it dictates how similar two data points are. Different kernel functions have varying complexity. Simpler kernels might lead to a simpler model, less likely to overfit, while more complex kernels allow for greater flexibility at the cost of a potential overfitting.